All right, good evening, everyone, and welcome to another edition of Virtual Starry Skies. My name is Joe Aiken. I'm the technical director of the Tung Visualization Lab in Planetarium here at Colgate University. So, thank you all for joining me this fine evening. Looks like it's going to be a clear weekend, so a great time to go out and take a look at the sky. So, speaking of the sky, there's actually quite a few planets out over the weekend. If you go out early evening, you got Jupiter and Saturn kind of due south. Mars is near the moon tonight, and we have Venus in the early morning sky. So, to kind of honor those planets, we're actually going to take a tour of our solar system because I know some of you probably have not had a tour of the solar system since you're in grade school. So, what better way to do it than to use our Planetarium software? So, let's go ahead and get started. All right, we're going to start off by visiting way out towards the edge of our solar system. Right there in the middle of the screen, you'll actually see our star, the sun. And remember that our sun is actually kind of a small, average, just kind of average, kind of smaller, kind of yellow star. Surface temperature about 10,000 degrees or so. But still pretty warm in the core, about 1,000,000 degrees. Our solar system is home to 8 classical planets. We have several dwarf planets, asteroids, comets, and a whole bunch of other stuff. So let's actually get started. We're going to fly in a little bit here. There you can see our sun. You can see the little dots. Those are actually some of the planets. And just kind of talk a little bit about the structure of our solar system here in the inner planets. We got Mercury, Venus, Earth, and Mars. Make up kind of what we consider the rocky planets or the inner planets of our solar system. And of course, we got the outer gas giants. So we'll turn off the inner planets. And outer gas giant planets way out here: Jupiter, Saturn, Uranus, and Neptune. And just kind of give you an idea of scale here, the inner planets, roughly the distance, we like to actually, to make it easier, we say the average distance between these planets and our star, we measure those in astronomical units. Remember, the Earth to the Sun is 1 astronomical unit. And what that equivalates to in miles, let's say miles, 93 million miles, just for the English units. So from the Sun to Mars, on average, is about 150 million miles, or 1.5 AU. Sorry, I'm throwing a lot of numbers at you. Out here, once we get out to the outer solar system, out to these gas giants, we start measuring things much bigger in scale. So Jupiter is about 5 AU. So Saturn is actually about double that distance, right around a little over 9 AU. Uranus even further, kind of double that distance, roughly 18 AU. Now, to kind of convert these into miles, Jupiter is on average about 400 million miles away from the Sun. Saturn is nearly 1 billion miles. Uranus is 2 billion. Neptune, 3 billion miles. And then, of course, out past the outer planets, we have these smaller objects that we classify as dwarf planets. So if we turn off those outer giants, one of the dwarf planets is actually close in that asteroid belt called Ceres. Of course, the largest dwarf planet is Pluto, but here are a couple others. We have Eris, Makemake, and Haumea. Now, if you notice right off the bat that the orbits of these dwarf planets are skewed to the rest of the solar system. And we'll get back to those in just a bit. Now, the rest of the makeup of our solar system, of course, we have the asteroids and comets. And so let me turn on our asteroids here. And we have to kind of go back in because remember, the main part of the asteroid belt, or most of the asteroids in the asteroid belt, lie between that region of space between Mars and Jupiter, and that's also where Ceres is located as well. So we put a whole bunch of dots. The different colors actually represent different types of asteroids. We're not going to talk about that there in this show. That'll be another time. Or if you saw one of our previous shows, we actually talked a lot about different types of asteroids. But here you can see most of the asteroids kind of lying in that belt between Mars and Jupiter. And if we zoom out, we have another region of asteroids called the Kuiper Belt. And some of these asteroids are they're not really asteroids. We actually consider them comets way out here because it's very, very cold out here near Neptune. And then if we keep going further out, the sun's gravitational pull actually extends quite a lot and actually can extend all the way out to what we call the Oort cloud, which is about the where all these kind of long range distant comets reside. And if we zoom out just up here, just so we can see the spheroid of lighter bodies kind of orbiting the sun here, to about a distance of 1 light year, or roughly 6 trillion miles. So as we zoom out, you can see all these Oort clouds, just millions of objects. And these are comets. These are going to be only a few meters across, sometimes a few miles across, the bigger ones. Of course, we had a nice visitor, a long-range comet that visited over the summer. And so here you can see that kind of just lots and lots of Oort cloud, lots and lots of comets here in the Oort cloud. Okay, so that's enough about the Oort cloud. Let's head back in because today we're actually going to be talking more about the planets. And just kind of give you an idea, let me go and turn on some orbits of the planets. And as we get closer here, we got to speed up because we were quite far away. So the yellow line is the orbit of Saturn and Jupiter, Mars. We're actually going to start out at Mercury. So let's fly all the way in here. Whoops, sorry, little fast. Okay, so I'm going to let the system take control, and we're actually going to fly right to our first planet. And let's take a look at Mercury. And as we look at the surface of Mercury, as we kind of take a little orbit around, Mercury is actually extremely, extremely close to the Sun compared to the rest of the planets. I say close. It's actually at a nice stable orbit, about 30 million miles away from the Sun, or 0.3 AU. Mercury looks a lot like our Moon, filled with craters. The size of Mercury is actually about 2.5 times smaller than the Earth. It orbits the Sun extremely fast, being so close, at about 88 days. And as we get closer, you can see these craters start to come into view. And the reason why it has so many craters, very similar to the Moon, that it doesn't really have an atmosphere. And so craters can come right through, nothing to erode away the leftovers of the collisions from millions of years ago, even today. But you can see Mercury, these is kind of a sort of a false color image, but Mercury is mostly gray that our eyes would see. The different colors actually represent different types of minerals that's in the soil here in Mercury. So it does possess kind of a thin, even though it doesn't have an atmosphere, it does have some type of interaction caused by the solar wind from the sun, charged particles hitting the surface of Mercury, kind of eroding away some of the surface. That interacting also with meteors that continue to strike it creates kind of this very thin composition of like oxygen and sodium, hydrogen, helium, potassium, and so forth. So we don't really consider it an atmosphere though. But again, Mercury is just filled. You can just see so many craters here. Now, cool thing about Mercury, the day side of Mercury, being this close to the sun, you expect it to be hot, and it is. It is extremely hot, roughly about 800 degrees on the day side. On the night side, minus 300. So if you like change of seasons, or at least change in temperatures on a daily basis, we'll get back to the number of hours it takes, or days it takes a day. But temperature variations, over 1,000 degrees between the day side and the night side. And that leads me to the rotation period of Mercury. It doesn't spin a whole lot. And over time, as objects orbit each other within a solar system, or like the moon orbiting the Earth, at some point it will actually set up so that the same side always faces the larger object. In this case, Mercury eventually is slowing down to the point where the same side will always face the sun. But right now, it's not quite there yet. Its orbit period is roughly 59 days. So that's how it rotates on its surface or around its axis 59 days. It takes 88 days to go around the sun, to revolve around the sun, to orbit around the sun once. So almost two rotations. Well, I guess one rotation per, or I guess two rotations per 1.5 orbits, or maybe a 3-to-2 pattern. So, very interesting here. So, if you want to spend a whole long day, you think our days are long, 24 hours, Mercury's day lasts 59 days. It's year 88 days again. Okay, so that's enough about Mercury. We'll come visit in another time. But we need to move on. So let's head actually to the next planet out at 60 million miles away from the Sun, 30 million miles away from Mercury, and that's, of course, Venus. So we'll say goodbye to Mercury here. We're going to fly through the Sun there. Quick little trip. Okay, here we have Venus. Now, Venus is sometimes known as Earth's twin. It's roughly the same size. Its rotation period is interesting that it rotates backwards compared to the rest of the planets and how they rotate and orbit. So it's actually backwards. It rotates 3 times for every 2 times it orbits. So it's rotating extremely slowly. It has a thick carbon dioxide atmosphere, which makes Venus shrouded in clouds, which means we cannot see the surface without other means. We have to use cloud-piercing radar in order to see the surface itself, and which we can do that if we take away the clouds, so we can see that surface. This is a radar-mapped image of the surface itself. We know Venus to be geologically active, filled with volcanic eruptions all the time, sulfuric acid rain. There's actually lightning here on Venus. There's some crustal movement. So, not a nice place to visit. Temperatures here on Venus soar up to 900 degrees, and that's all the time. So, unlike Mercury, where it dissipates heat as it rotates, not so much here on Venus. It's actually 900 degrees all the time. We did some spacecraft early on in our robotic history back in the 70s. And we actually captured a couple of images. So here's one right here. And this is it lasted about 15 minutes to capture this image and send it back before it melted under the intense heat. And by first look at Venus here, you might notice it kind of looks like Mars. It looks kind of dry. Well, we kind of landed in a good day on this one particular point. But there you can see some rocks structure there straight ahead of the lander. But again, it is not all that dry. Again, filled with lots of volcanic eruptions and whatnot. Okay, so let's turn off this image. Now, just kind of give you an idea of what it might look like to land on Venus. We just have a kind of what the clouds might look like based on that image that you saw before. This is, again, an artist's rendition of this. But imagine volcanoes spewing out and these kind of sulfuric acid rain clouds coming at you here. Again, if we were to know them, you really get a sense of the experience. Now, remember, Venus actually being 60 million miles away from the Sun, it also orbits around the Sun not as long as Earth, a little bit smaller or shorter year, about 225 Earth days orbiting around the Sun. There's actually huge mountains and valleys here on Venus. Like I said, it is geologically active. One of the largest mountains on Venus is about 20,000 feet high, which is comparable to Mount Everest. Not quite as tall as Mount Everest, but fairly close. Okay, so let's move on from Venus because we gotta get to the other planets in our solar system. Alright, so we know the Earth and our moon. We'll have to come back for maybe a moon show later on. So let's actually keep flying out. And let's fly over to Mars. We'll kind of skip over the Earth. Now, Mars is about 150 million miles away from the Sun. And let's head on over there. And you can actually see Mars again if you go out in the early evening sky. Well, kind of late evening. It's rising roughly around 10:30 on the horizon. It'll get higher up in the sky by 11:30 is a really good time to see it because it's extremely bright right now. We just passed what we call opposition, which is our closest approach to Mars. All right, so as we get a little bit closer here, you can start to see kind of the surface of the red planet. Mars is actually much smaller than Earth. It's about half the size. But it has some very big features on it. We always talk about Olympus Mons. Here you can see these what's called the Tharsis Ridge, which are the three largest volcanoes, some of the largest volcanoes in our solar system. The largest one is right here called Olympus Mons. And we can get right down to the surface so we can see it. And we'll get a little bit closer here. Now, Olympus Mons is a massive volcano, roughly 3 times taller than Mount Everest. The base, the size of it, is roughly about the size of New Mexico. I would say it's almost about the size of New York. It's not bigger than Texas, though. We know Mars probably once had a watery past because we see these dried up riverbeds and dried up valleys and lakes. There's quite possible, and we think there's actually a huge layer of ice underneath the surface. And sometimes it might get warm enough where it might melt that layer of ice and bubble up to the surface and cause mudslides. We have seen recent evidence of that. We do have a new rover heading to Mars called Perseverance, and it's going to be landing in the Jezero crater. Before I talk about that, I just want to pan down a little bit down into kind of more towards the equatorial region. And we're actually going to bring daylight to this region of Mars just because I want to show it here. So this is a huge scar on the surface of Mars. This is called Valles Marineris. If placed here on the Earth, it would stretch all the way from Los Angeles to New York. It's over 3,000 miles long and about 5 miles deep. The Grand Canyon would easily fit inside one of these tributaries here. And if we go down to the surface, we can kind of fly down as if it was filled up with water, it'd be a great kayaking trip, right? It might take a while. So Mars actually might have been warmer and wetter, much like the Earth. Here you can see some of these eroded valleys. We're learning a whole lot about Mars every single day with all of our robots and probes there. So let's actually head over to that other crater that Perseverance is going to be landing at shortly. So to get a better look at it, it's going to take us kind of right on over, so give it time. I just want to brighten it up so we can actually see it when we land. It's all the way on the other side of the planet here. The blue circle is kind of the area that we think it should be landing. But you never know. You never know what's going to happen. So we actually have a nice high-resolution terrain map. So if we go down to the surface, we can actually see a lot of detail. Because that's one thing that we wanted to do is actually map out the surface, the landing spot in great detail so we can land it properly without crashing into a crater or into a large boulder. So Jezero Crater is actually this large one way up here. And if we get a little bit closer, you can see why maybe NASA chose this for a landing spot, because there's a unique, a wide variety of surface detail here. So here you can see these mountains and valleys. You have eroded channels. So this is a very interesting place to see on Mars. And we can go down a little bit closer. You almost might see what we consider maybe sand dunes. As we get a little bit closer here, there you can see some of these. Again, this is a vast area. It's a vast crater. Hopefully it'll give us some clues to Mars' ancient past. Okay, so moving on here. And we did a whole show on Mars just about a month ago now. Okay, so let's keep flying up. And remember, Mars does have 2 moons. I can't fail to mention those, Phobos and Deimos. You can sort of call them moons. We call them moonlets. If you think about it, they're actually very tiny, very little mass. They're kind of look like potatoes, and we think they were probably captured asteroids at Mars. Grabbed it. So let's fly out of Mars. Let's go to our next big planet, and that's of course is Jupiter. Jupiter, the king of the planets, largest planet in our solar system. Over 1,000 Earths can fit inside it. No longer the king of the moons, but it still does have about 79 moons currently. And as we come, you can easily spot all the cloud tops here on Jupiter. You can see the great red spot there. Jupiter, again, over 1,000 Earths can fit inside it. If you took all the planets, it could actually easily fit inside Jupiter with room to spare. You might notice a little black dot there in the clouds. That's actually a shadow from one of its moons. And if you're good with a telescope and you're looking at Jupiter, you might actually be able to see some of these shadows. And you see all those little dots that were flying through? Those are actually part of its ring system, because people don't usually know this, but Jupiter does have a ring system. It's just very, very faint. It's kind of hard to see, more like ring arcs. Made mostly of dust, and we're going to get to the Lord of the Rings in just a bit, just after Jupiter, of course, when we go to Saturn. But you can kind of make out some of those ring systems. And we might do a whole show on Jupiter and its moons. But as we get closer, this is actually a map kind of composited together of the Juno spacecraft, which is now at Jupiter, and Galileo spacecraft that was there back in the 90s and early 2000s. So Juno's been busy mapping mostly the polar regions here on Jupiter. And if you look, there's a lot of storms, a lot of swirlies, if you will, all around here on Jupiter. Some of these storms are actually bigger than the planet Earth. We're still studying Jupiter. We know there's lightning on Jupiter. Roughly lots and lots of kind of layers of atmosphere here. And some of the storms actually tower high in the cloud tops. And there you can see more storms as they appear. A few years back, some amateur astronomers were looking at Jupiter and noticed another red storm. It's now turned white. But we do have another kind of big storm here on Jupiter that's about half the size of the Great Red Spot. And so we're still learning a lot more about Jupiter and its cloud tops. Thanks to Juno, we'll be getting a lot more. So here's actually captured on one of those images, the merger of 2 storms, which happens a lot. The Great Red Storm, we like to see like storms kind of get sucked in and then spit back out as it goes along. All right, so there is Jupiter. All right, moving along. Let's keep going here. So we'll say goodbye to Jupiter, and we'll go to the Lord of the Rings next, and Lord of the Moons. That is Saturn. And Saturn actually, like I said, now we're at 1 billion miles, nearly 1 billion miles away from the sun. Saturn is so light for its size, it would actually float in water. Total number of moons right now we've detected is 82. That number continues to go up as we're finding able to detect smaller and smaller moons. There you can see that extensive ring system. If you were looking at Saturn through a telescope, you might see it kind of more like similar like this, where it might be slightly edge on right now, or slightly tilted, so you don't see the complete ring system. It's actually blocked by the planet itself. And remember, the rings, the colors actually come from the cloud tops of Saturn reflecting back onto the rings. The rings are not solid. They actually are made up of billions of tiny icy covered rocks, mostly made up of dust and ice. Unlike Jupiter, where the ring is actually made up of mostly dust, here the rings of Saturn are made up of a lot of ice. And so as we go in, let me slow down a little bit here. There you can see all those individual particles making up the ring. I'll try to get us in orbit here. Try not to spin too fast. And as we orbit around Saturn, we'll kind of fly through the rings there. Now, if you notice something interesting about the rings, there are gaps. They're not, not even solid within each other. Why do you think that is? What could be in these gaps? So if we zoom out, you might lend a hint here. And if we zoom out a little bit more, and let's go traveling to something that's in these gaps. So if you notice, there's these little white dots. All these little dots are actually its moons. We've scaled them up so we can see them. And if I'm really good, and if I slow down, we might be able to actually take a look at one of these. So, in these gaps are actually moons. These are what we call shepherding moons, which keep the rings kind of intact. It's the gravitational forces, even though this particular moon is really small, and it's like hamburger shaped and very flat due to gravitational tugs. It's not large enough to actually make a sphere like our moon. But gravitational interactions between these small moons and Saturn itself are what keep the rings kind of intact. Now, the rings closer to Saturn, when Cassini was there, which is a spacecraft that was orbiting Saturn from the late 90s all the way through the 2000s, detected that as it flew through these rings and through between Saturn and the rings itself, it found particles flying off the rings and diving into Saturn, actually being absorbed by Saturn. So we think Saturn's slowly eating the rings. Alright, so let's go a little bit closer through the rings here. Also, some of the structure of the rings, these moons actually cause these gravitational interactions. You see kind of wave-like patterns along the rings. So there's some really interesting dynamics happening here at Saturn and its rings. In Saturn itself, the ball is actually about 95 times bigger than our Earth, which makes it much smaller than Jupiter. But still very, very massive. And there you can see that shadow being cast by Saturn. And when Voyager flew by Saturn, it got us one of the best images, well, one of the only images that we've seen where you can see the night side of Saturn. Of course, we don't get that from the Earth because Saturn, we never get to see the night side of Saturn because it's orbiting far away. And what we call a superior planet, meaning it's past the Earth, we only see the day side of Saturn. So Cassini and, of course, Voyager gave us these fantastic views of the night side of Saturn. This really doesn't do it justice, but we'll save that for another time to show that beautiful night side image. Okay, so let's fly out Saturn and her rings. And we'll move on to our next gas giant. I want to be cognizant of time. It's almost 7:30 already. So our next planet that we're going to be flying to is, of course, Uranus. The seventh planet from the Sun. It's actually the third largest in diameter of all the planets. But imagine if Jupiter was the size of a basketball, Earth becomes the size of a ping pong ball, all right? Uranus is about the size of a softball. So it's actually much, much smaller compared to Jupiter, but still about four and a half times bigger than the Earth. So it's still much larger than the Earth. Now, we don't know a whole lot about Uranus. It's very bland. It's actually this kind of pale green color, and that's due to mostly the methane that's in its atmosphere. It's nearly 2 billion miles away from the sun. It does have quite a few oh my gosh, quite a few moons. 27 to be exact. The strangest thing about Uranus is that it's tipped on its side. One, not only does it rotate in the opposite direction, just like Venus, but it's tipped on its side. Which makes, like, if you're on the pole, you have a day of 21 years long. And then a winter just as long. It takes 84 years for Uranus to orbit the sun once. And just kind of give you an idea of what this looks like when it's tipped over. There you can see the sun in the distance. And it does have a ring system. Very small ring system, again, made mostly of ice. Because remember, way out here on the outer edge of the solar system, it's extremely cold, about 300 to 400 degrees below zero. Now, Uranus is actually, again, the third largest planet. The fourth largest planet is its neighbor, which we're going to next, another billion miles away, and that's Neptune, which is very similar in color. But Uranus is a little bit brighter, kind of this lighter blue color, kind of bluish green. Again, due to most of the methane that's in the outer atmosphere here. And it kind of absorbs most of the red portion of light spectrum and kind of giving off this kind of blue-green color. Neptune is a slightly different atmosphere composition, and it's very deep blue. And we think that most of the mass of the planet is actually this kind of what we quote-unquote hot kind of dense fluid of icy material. It's almost considered an ice giant rather than a gas giant. It's kind of thick in nature. Compared to like a gas, made mostly of like water, methane, ammonia, and there's actually still a rocky ice kind of rocky core at the center. But as you near the core, due to the pressure, temperature is actually near the core of Uranus itself, we think is about 9,000 degrees due to that compression, which makes it have a very warm core, which might have contributed to this kind of hot, dense fluid of icy material in its atmosphere, or kind of surrounding that core. All right, well, let's go visit the last gas giant in our solar system, and that is, of course, Jupiter, or oh my gosh, Neptune. So as we fly out to Neptune, we're traveling another billion miles now. Again, Uranus about 1.8 to 2 billion miles away from the sun. Here we are at Neptune, nearly 3 billion miles away. And I didn't mention about Jupiter, Saturn, Uranus, and Neptune. We thought the winds back in the 70s when we were launching the Voyager probe, we thought, the further away you get from the sun, we have detected winds over, especially like hurricanes and stuff here on the Earth, 150 miles an hour. Tornadoes, of course, can spin up much faster. But the cloud tops on the Earth, at most, 75 to 100 miles an hour on average in the jet stream, sometimes even faster. Mars, you get pretty fast at 150 to 200 miles an hour. When you get to Jupiter and Saturn, you get a little bit faster. Uranus and Neptune, winds whip around the planet at 2 to 3 to 400 miles an hour. It's extremely fast. We're finding faster winds out here in the outer solar system. So here you have Neptune, that deep blue color. If you have a large telescope, you can actually see this blue planet. Not much in the way of clouds here on Neptune. You'll get a few kind of white wispy clouds. And at times you might get storms that might build up. And it's, again, about 4 times bigger than Earth, so a little bit smaller than Uranus. And it's just like the other ones, it does not have a solid surface. But the atmosphere is made mostly of hydrogen, helium, and methane. And we think, actually, as you go deeper into the planet itself, all the material actually condenses and merges into like a watery and kind of melty, liquidy, icy layer, and then a solid core underneath that. So we're still learning a lot about these outer gas giants. Again, it's so far to get to these that we don't have any spacecraft here anymore. Voyager just did a flyby, and it was Voyager 2 that did that. So we need to send other probes out here to Neptune. But who knows when that's going to happen. Now, if you notice, we did fly a couple of rings. Neptune does have a small ring system, again, made mostly of ice. One of the strangest things about Neptune is one of its moons, a large moon by the name of Triton. And let's fly over to Triton real quick. It's not quite the largest moon in our solar system. This is a fictitious kind of surface that we put on the model, but we do not have a complete map of the surface of Triton. When Voyager flew by, it detected actually a thin atmosphere. It found ice geysers. These are like ice volcanoes that spew water ice out into space, miles high, well above the surface. The temperature it detected about 390 degrees below zero. So very similar to the conditions that you might find at Pluto, which we're going to be visiting just next. So this strange world we need to get back to at some point, because there's just some really interesting things happening here on Triton. We think, what could be causing these gyres? If the surface is 390 degrees below zero, there must be something warm underneath. And indeed, like in Uranus, where you have kind of a hot core, maybe there's something warm here that's causing some liquid and spewing and changing the surface here on Triton. So we still don't know why. There's a lot of research to be done, but very cool planet, moon. And this is the only moon to actually orbit its planet backwards. So compared to the rotation of the planet itself. Out of all the other moons, this is the only one that actually orbits opposite of the other moons here on Neptune. We think that Triton was probably a captured object that got a little bit too close during the early formation of the solar system, and Neptune captured it, and now it's a moon. Okay, so let's fly out of Neptune and her moons, and we'll visit a couple of dwarf planets here at Pluto, and then we'll probably have to say goodnight because we are getting late in time. So let's fly over to Pluto. Pluto right now has switched back places because Pluto does have a weird orbit, and every 260 years or so, it actually, or 240 years, 240 to 250 years, it switched places with Neptune. Pluto we visited for the first time with the New Horizons spacecraft, did a quick little flyby and actually mapped some of the surface. And here's what it found. Once we thought was a dead world, just a big ball of ice, turned out to be so far from the truth. There's geologic activity here. There are ice volcanoes. There's this huge glacier there on the surface. You can kind of see it here. This harsh-shaped glacier that is changing over time. It has these convection cells here on the planet. If you know what winters are like up here in upstate New York, if you look at a frozen lake, you might see these convection cells as the ice below it or the water below it is a little bit warmer than the ice itself. So there's something maybe liquid underneath this glacier causing these giant convection cracks in the ice here. There are very complex like hydrocarbons here on the surface. Water is frozen solid as rock. We detected a very thin atmosphere, made mostly of nitrogen here on the planet. Nitrogen is also frozen on the surface. It kind of might ice nitrogen, if you will. So really interesting things here about Pluto. Again, we do not have time to go into great detail right now, but maybe for another show we will focus on Pluto and the other dwarf planets. What's also cool about Pluto is there's 5 moons here orbiting Pluto. The largest one, Pluto could even almost be considered a double planet. You can kind of see it off there in the distance. That's its moon Charon, or some people like to say Charon. And we can actually take a quick little trip over there. Charon is about half the size of Pluto itself. They do not orbit, Charon does not orbit Pluto. They actually orbit a common center of gravity, which means that this would almost be considered a double planet. We think maybe something like a collision causing the two objects to split apart. But Charon is also really interesting. We didn't really get much time to look at it, but here's some of the surface mapped as New Horizons kind of flew by. It also has some geologic activity. Again, really interesting here, out here on the outer edge of the solar system. Okay, so let's fly out here. And I'm just going to put up the orbits of all of our objects here in our solar system, just kind of give you an idea of how strange things are way out. So we're going to have to zoom way out here. And we'll just kind of tilt down to kind of get out of our solar system, just kind of give you an idea of how strange the dwarf planets are compared to the rest of our solar system in the orbits. Pluto is kind of the most normal out of all of them, but you can see some go way out and are highly elliptical, behave more like comets than they do planets. All right, well, we are actually out of time. So, of course, let's actually head back to Earth here. We'll take a quick trip back. I'd like to thank everybody for tuning in, and hope you guys enjoyed our little trip around the solar system. And we'll be back again next week. Since our students are back, they're going to start producing their own shows and their own content. So stay tuned on that. We'll be advertising that shortly. And for our next show, we'll be back next Friday at 7 o'clock. So again, thank you very much for coming. And go out and enjoy the night sky this weekend and enjoy the planets. Definitely take a look at them. Even with a pair of binoculars, you can see some really cool details. So again, thank you and have a great night.